187 here. We're going to introduce our basic terminology for angles. So to the left here, we have our definitions. To the right, we're going to have our pictures of our diagrams. So two distinct points determine a line, AB. That's this picture right here. Notice that you are going to extend both to, if we were to say positive infinity, negative infinity, if we were thinking of this as a number line. Now, a line segment, AB, is a portion of the line between A and B, including the point A and B, two definite endpoints. That's a line segment. Next, we have a ray AB. It's a portion of a line, AB, that starts at A and continues through B and goes past B. It goes on forever. Now, again, when you notice this notation in the books or in homework problems, if they're talking about line AB, you will see a picture of this line above the two letters. If we're talking about a segment AB, you will see this picture above the two letters AB. Not too often do they use the endpoints. It'll just be a straight line segment. And if they want a ray, they will have this picture above the AB. Especially the A will always get the non-arrow end. So whichever letter is first is your starting point. And the second letter getting the arrow tells you which point we're going through and beyond. An angle consists of two rays in a plane with a common endpoint. That common endpoint is going to be called our vertex. The two rays, which are sides, connect to the vertex at that common point. The angle's rotation is generated by a rotation about this vertex, and it can go in either direction. We have the initial side of your angle, and it rotates to the terminal side of the angle. Now, if they draw this arc figure in the diagram, it could be going in the other direction. If that happens, then the arrow always points to the terminal side, and the beginning of your arc arrow, if you will, is always your initial side. So if we did turn this around, this would be the initial side, that would be the terminal side. Angle measures. We have positive angles and negative angles. The rotation of the terminal side of an angle is counterclockwise, going in a counterclockwise direction. That will give us positive values for our angle. If we go in a clockwise direction, that would be a negative angle measure. The most common unit of measuring angles is the degree. Now, degrees are closely related to, if you will, a standard, what I would call a wall clock, 1 through 12 on it. One complete rotation of a ray gives an angle whose measure is 300 degrees, a complete circle. Now, our angles are broken down into different measures. So to classify our angles, you have an acute angle is always between 0 and 90 degrees. It's never 0, it's never 90. If it does equal 90, we call that a right angle, indicated by this little box in the corner. An obtuse angle measures past our 90-degree right angle to 180 degrees. And if we go to 180 degrees, that is a straight angle, again, forming a straight line. So every straight line measures 180 degrees. Complementary angles, this is when you have two positive angles whose sum is 90 degrees. Supplementary angles, two positive angles whose sum is 180 degrees. Now, one way for you to remember that is think about alphabetical order. C comes before S, 90 comes before 180 degrees. And it's also very important to know that these two angles, these two positive angles, do not have to be touching each other. They don't have to be sharing the vertex. They can be off anywhere they want. All right, so let's find the complement and supplement of an angle that measures 55 degrees. So if I'm looking at complement, the quickest way to do that is simply go 90 minus 55, and that would equal 35, so we'll call that 35 degrees. A supplement angle, we now just do 180 degrees minus 55 degrees. That's 125 degrees. Number 2, finding measures of complement and supplementary angles. Most common problems that you see here is they'll ask you to solve for a variable, in this case x, and then turn around and find the angle measures once you've found x. So here in our first diagram of A, we have a definite right angle, so that's 90 degrees. So this 2x degrees plus 3x degrees has to add up to be 90 degrees. And if you want to drop the degrees, you can and just call it 2x plus 3x equals 90. We'll add our 2x terms, call it 5x, divide by 5, x is equal to 18. So now that you know the value of x, we'll substitute that back into both angle measures. So 2 times 18 is going to be 36. That will be a 36 degree angle. 3 times 18 is 54, so we have that being a 54 degree angle. And if you want just a quick double check, add those two together and they better add up to be 90 degrees. Over here, B, like we said, we have a straight line that measures 180 degrees. So these two angles here have to add up to be 180. Again, if you don't want to work with the degrees, you don't have to. 2x plus 7x, that's going to be 9x. 9x equals 180. X equals 20 when we solve for x. Plug into the 2, that'll be 40 degrees. 7 times 20 will be 140 degrees. And there are my two supplementary angles. Okay, parts of a degree. This you want to pay close attention to because you will be tested on this for sure. We're going to look at decimal degrees versus angles that are in degrees, minutes, and seconds. So if you remember, I said degrees is a lot like a wall clock. One complete revolution is like 1 hour. There's 60 minutes in 1 hour. There's 60 seconds in 1 minute. Okay? So 1 minute is 1/60th of a degree. So 1 minute, which is represented by your accent mark or your apostrophe on your keyboard, is equal to 1/60 degrees. Or 60 minutes is equal to 1 degree. 1 second is 1/60th of a minute. So now it's like the quotation marks, one double accent mark, however you want to say it, is equal to 1/60 minutes. There's the single accent, or 1/3600th of a degree. Now, under 3600, you might want to put down 60 squared. That's more common because we basically have to multiply 60 times 60. And we use the calculator a lot here, and it's easier to type that in. Or again, there's 60 seconds to 1 minute. So if we're going to convert between these two forms, and again, you're going to have to demonstrate this by hand, show all the work on the test, so practice this as much as possible. To go from 12.675 degrees into degrees, minutes, and seconds, we already have our whole degree, so put 12 degrees in your answer. To get to the minutes and seconds, now take the decimal portion, 0.675, and you multiply it by 60. That's 40.5. So the 40, the whole number here, is now going to represent your minutes. Then take the remaining decimal, 0.5, multiply it by another 60, and then this will be your seconds. Now, pay close attention to the directions because a lot of times they're going to say round to the nearest second. So we'll round this to the nearest whole number of seconds. In this case, it just happened to be perfectly 30, so we have 30 seconds. To go from degrees, minutes, and seconds to a decimal degree, well, the 21 degrees, that's your whole number on your decimal. You need a calculator here for the rest of this. So here's your calculator entry. And I'll bring my calculator over onto the screen so we can work it out together. So what I would do is we're going to go 45 divided by 60 plus 36 divided by 60 squared. Just a little quicker and easier to type that in to our calculator. 0.76. So there's my screenshot of the calculator entry, 70.76. There's my degrees.